I gotta admit, I remember seeing this problem and I thought for a second that I couldn't solve it, but it's actually pretty easy. Let me show you. So in this particular problem, they want us to find the limit as h approaches 0 of 1 over h times the integral from 2 to 2 plus h of sine of x squared. And the trick here is that we can't really integrate sine of x squared. That's a for now integral. So we're gonna go ahead and rewrite this in a couple ways. So first, I'm just gonna go ahead and rewrite the limit here. I have this integral on the top. So 2 to 2 plus h sine of x squared dx all over h. So I just rewrote it as a fraction. Now, if we use direct substitution, meaning we plug in 0 for the value of h, we're gonna have 0 on the bottom, and on the top we have 2 to the integral of 2 plus 0. So we have the integral of this function from 2 to 2. Well, according to just integration properties, that right there is going to be 0. So what we have right now is we have a limit where you get 0 over 0. So we can go ahead and use L'Hopital's rule. Now on the bottom here, when we take the derivative with respect to h, we're just going to get 1. So that's going to be pretty simple. And on the top, we're just going to take the derivative of this integral here. So what we're going to go ahead and do is implement the second fundamental theorem of calculus. And that tells us that the derivative of this function here is going to be sine of 2 plus h squared times the derivative of that value, which is just going to be 1, so we're good. And then now, once again, we can go ahead and use direct substitution again, and we get an answer of sine of 2 plus 0, so that's going to be 2 squared. So we get sine of 4 over 1, whatever that is, and that is a solution to that particular problem.